So in the last, before MSc, right, we have started the portion GPS, right? Right. So GPS stands for Global Positioning System, right? Am I audible? Hello? Can anybody give me feedback like? Okay, okay. Right, so it's a GPS is a navigation system which is based on the satellite, right? So let's in the first 5-6 minutes we will revise what we have seen in the last lecture, right? This GPS has created the revolution in the navigation and the position location, right? And it is mainly used in the positioning, navigation, monitoring, and surveying application, right? So still we will study the application like the GPS has a application in uh, like marine in environment, that application with land, right? So we'll see the detail, but we can say like it's used mainly for positioning, navigation, monitoring, and surveying application, right? And if we'll talk about the history, like how GPS was started. So initially focus was mainly on military target, right? And fleet management and the navigation, commercial uses. Uh, but the navigation and commercial uses, right? Nowadays we have started to use GPS in this field also, right? Uh, So, like, we'll take the advantage of radio location where extended to tracking down the stolen vehicle, right, and guiding the civilians to nearest some location which will enter, right. So, all of you have used the Google Map, right? So you can enter some location name, some hospital name, some police station, some hotel name, and it will show you the path. The major advantage of GPS is, or we can say like satellite navigation, a real-time position, right? So like maybe you have experienced that when you enter the location in Google Map, it will show you like if you go to through this route, then it will take this time. In this route, you may have the traffic or some work will going on some road, and that road is blockage. Right? So the Google Map will also provide that information. So it's a real time data, right? So it's provide real time positioning and timing synchronization, we can say, right? And that is why this satellite navigation has become an integral part of most of the applications, right? Where we can say like mobility is a key parameter, right? You are dealing with something in which the mobility is there, right? Then you can use the GPS, right? So we will talk about this system. So system is made of a network of 24 satellites, right? So these 24 satellites are continuously, we can say like it's moving around the Earth, right? So this system is called as a NavStar, right? Navigation system with time and ranging, right? And these 24 satellites are placed in 6 different orbits, right? So around the Earth there are 6 different orbital paths, right? And in each path there are 4 satellites. So total in GPS we have 24 satellites, right? And through these 6 orbits, right? And with 24 satellites, we are covering the entire Earth. Right? So we can find any location on the Earth. So the group of the 4 satellites which are in the same orbit, right, are called as a, that group is called as a constellation, right? And any two adjacent such group, right, are separated by 60 degree in the longitude. So we know like if you draw a horizontal or vertical lines in straight line, right, from middle point you can say like the two line have angle of 180 degree, right? So to cover the entire 360 degree, we can say, right? You if you separate the 6 orbit, right, using this 6 degree difference, then you can cover 360 degree, right? This orbital period, like a single satellite, right, it need 12 hours to complete its orbital path. So you can say a satellite will complete its revolution, right? Complete movement, right? That is of 12 hours. So within a day, satellite will move 2 times around the Earth, and it will continuously sending the satellite, signals to the Earth, right? It's continuously sending the signal. We can see the receiver, and to find the location at a time, you just need the data from at least 4 satellites, right? There are total 24 satellites, but you need only 4 satellite data to find the location on Earth. Uh, so the satellite signal can be received anywhere and any place in the world. So in this figure, you can see like if you count that are the total 6 orbits, right? And each orbit you can see like 4 satellites. Right? Have one GIF, right? You can see like from a point on Earth, you can see uh, at a time at least 6 to 7 satellites are visible, right? We just need the data from 4 satellites only. But you can see like here, you can see in the below it's written 9 visible, 7 visible, 8 visible satellite, right? They have selected one location, and the satellites are continuously moving in their orbit, right? And Earth is also moving, right? Earth is also you can say moving on its axis, right? Okay. So the spacing of satellite is arranged such that a minimum of 5 satellites are in view from every point on the globe, right? So minimum 5, but you can see like more than that are visible. Uh, so the first GPS satellite, right, that was launched in February 1978. Each this satellite is expected to last approximately 7.5 years. So its satellite lifetime, that is 7.5 years. And after that, continuously replacements is occurring. Right? So we need 24 satellites. Right? So if some satellites life is over, then that satellite is replaced with the new one. Each satellite is placed at an altitude of around 10,900 nautical miles, and the weight of the satellite is around 862 kg. Right? So it's approximate data. So around you can call like 800 to 900 kg weight satellite has. And if we talk about the size, then size is about 17 feet, or we can say 5.2 meter, right? And in that size will include the solar panels, right, which occupy the more space. And each satellite is transmitting 3 frequencies. Right? We'll see the kind of working about that. Uh, Now this GPS is based on the well-known concept called triangular technique, right? So triangular technique, we'll see in the detail. Right? So you can see like here, in the figure there are three satellite, and using that three satellite we are getting the location of 2 points, right? Which are the intersection. Like if you consider the satellite as a center, and around that if you consider the sphere, right, then the intersection of the sphere, that point, that location we can find. So this triangulation technique, select if you consider a GPS receiver mobile station, right, which is placed on an imaginary sphere, right, and the radius of imaginary sphere is equal to the distance between the satellite and the receiver on the ground. So receiver on the ground means, for example, you want to find the location of yourself, then you are the, you can say, receiver, right? So you have to consider the radius, the distance between satellite and you, and using that radius you are creating a sphere, right? And in the center you have the satellite. Let's give them its name as A. So now what you have to do, you have to consider two more satellite, right? We will call it as a B and C. So the second satellite B, right? You have to also consider the sphere around that satellite, and the satellite is at center, right? So when you form such sphere, right? So somewhere these two spheres are intersect with each other, right? And then you will consider the third satellite C, right? And you will take the intersection of this sphere around this C, right, with the satellite A and B. So actually what happening here, we are considering three satellite from the receiver to the, these three satellite, you are considering the distance, the radius, and you are going three sphere, and you are taking the intersection point. So using uh, this method, like that intersection point we can find, right? That location of that intersection point we can find, and from that we'll take that as a reference, and from that we'll find the GPS location of the receiver, right? Then we have seen some satellite navigation system apart from the GPS, right? So different countries have developed some different such navigation systems, right? This GPS is globally used, right? So all over the India we are using that, but some country uh, like China, People's Republic of China. So China and some country in the neighbor of China, right? They are using, they can use navigation system called Beidou, right? And that is developed in some 2019. Right? Then the second is Galileo, right? And that is developed by the European Union, so some European countries. Right? And it was that project was started in 2016, and they expected to complete it by 2022. Maybe that project is already over, right? But still in GPS also, every day the scientists are doing the research, and they are adding more and more functionality, right? More and more technology. Then GLONASS, it's a Russian global navigation system, right? And it's fully operational worldwide. Then NAVIC, right? So that NAVIC is developed by the Indian Space Research Organization, right? ISRO. So they have developed this navigation system, NAVIC. Then Mitsubishi, it's a regional navigation system, right? That was mainly focused on Japan and developed by Japan, right? So it will cover some Asian Ocean region, right? So it covers some Asian region. So if we talk about how the GPS will work, right? So one poster is, you can see that I have downloaded from GPS official government website, right? So the font are not visible. So let me show you So you can see in this, you have in which I have shown the 4 satellite, right? So one satellite is here, second one is here, third one is here, and the fourth one is here. Right? So I have shown the 4 satellite. Here you can see, and here we want to find the location of this particular vehicle. Right? So here we'll talk about the process or how the location or how GPS will work. So first we can see like the GPS satellites broadcast the radio signal, right? Providing their own location, status and precision time from onboard atomic clocks, right? So they will send a signal, right, with that will provide their own location, status and precise time when they have transmitted, right? So all the satellite have their onboard atomic clock, right? So they will transmit that signal and they will note the time t1, right? See, same way that process is repeating by, we can say, like all the satellite, right? Then the GPS radio signals, right? The signal will travel through space at the speed of light. So the signal has the speed of light. So that is around exact the value is 299,792 kilometer per second, or approximately you can say like 3 into 10 raised to 8 meter per second, right? So at that much speed the signal will travel, right? And they will reach to the device. So a GPS device receives that radio signal, noting their exact time of arrival, so that is t2, right? And use these two value t1 and t2, right, uh, to calculate the distance from each satellite, right? So satellite signal is providing its own location, uh, the time when they have started, when they have transmitted their time, and the receiver side, it will note the time when they will receive. So that two time, the distance, right? So we need to find the distance, right? So we know the speed of the signal, right? So the equation for speed is equal to distance by time, right? So you have three quantity: distance, time, and speed. So let me, is it visible properly, the PDF? Hello, hello.
Yes, sir.
So let me, it's S only, right? So speed is equal to, we know, distance by time, right? So this is your satellite and this is your target, or we can say the object or receiver, right? So from this to this distance, this d we want to find, this d we want to find. So we are transmitting a signal, right? So the starting time t1 and the receive time t2 we know. So the difference of these two time t2 minus t1, right? So this difference is the time needs to travel the signal from this point to this point, right? So this is the t, right? And the speed of the signal we know, that is the speed of light. So that is 3 into 10 raised to 8 meter per second, right? So in this we have the formula S is equal to d by t, we have S, we have t, so this d we can find, right? So d is equal to nothing but the S into t. So this distance from each satellite is nothing but the difference of the time of receiving and the transmitting into the speed of light, right? So that is 3 into 10 raised to 8 meter per second. So you can call like some 299,792 kilometer per second, right? So that way you can find the distance. So that, so here you can see that formula, right? So to calculate the distance from satellite, GPS device applies the formula which is distance equal to rate into time, and this rate is the speed of light, right? So here rate is nothing but the speed of light, and time is how long the signal will travel through the space. So that is the difference of t2 minus t1, right? So the signal travel time is the difference between the time broadcast by the satellite and the time the signal is received, right? So that way we can find the distance, right? So uh, so this is how the satellite GPS will work, right? So once the GPS device know its distance from the at least 4 satellite, it can use the geometry to determine its location on the Earth in 3 dimensions, right? So this 3-4 distance, you know, like the distance from 4 satellite to the object or receiver, you know, using that 4 distance you can easily find the location on the Earth in the 3 dimension, right? Okay. Uh, any doubt? Hello? Hello? Any doubt?
No, sir.
Okay. This actually this we can say like this method, right? Whatever I explained how the GPS will work, it's also known as a trilateration method, right? So it's tell us like how we can find the position using GPS, right? So uh, so Earth are it's covered with a number of GPS satellites that can help to determine your location on the planet. The concept behind the GPS positioning is very simple, but the application and the implementation require amazing precision, right? Definitely, uh, the way I explained, right? The way it's generally using a simple formula, right? Just uh, the location, the distance is equal to rate into time, right? So that is very simple, but the accuracy is need, right? The precision, it's like it's more important, right? So to get the precision, it's a difficult task, right? So for that they use that kind of devices. Uh, so you can say like this GPS positioning works on the two basic mathematical concepts, right? The first called this trilateration, which literally means the positioning from 3 distance, right? That we have seen. The second concept is relation between the distance travel, okay, distance travels and the rate of the speed and the amount of the time spent for traveling, right? So distance is equal to rate into time, that, right? Uh, right, so we know like we can't we don't have such measurement system like using some physical like yard stick or tape. We can't measure the distance from satellite to particular thing on Earth, right? So for that definitely we need to use such kind of technology or such kind of method, right? uh, that we have already explained, right? How the rate is the radio signal traveling rate speed, and that is the speed of light, right? That we have seen. Then the time, so its time is the difference between the time of transmitting from the satellite and the time when signal is received, right? So that difference is time, and the distance is just the multiplication of time and rate. So once we have the distance from at least three satellites, generally we are finding distance from 4 satellites, but at least if you have 3 satellites, distance from 3 satellites, then we can easily determine the three-dimensional position on the surface of Earth, right? So this trilateration It's determining your position by knowing your distance from at least three known points, right? Now let's talk about the application. So first we'll talk about the application, the aviation. So So in the aviation, we can say aviation is related to the aeroplane, right, or uh, aircraft. So the aviation through the world uses GPS to increase the safety and the efficiency of the flight. Right? So whatever the efficiency or safety we get when we travel with flight, right, that is because of GPS. Right? Because they are continuously providing the location to the station on the airport, right? Or they are also like continuously getting the information like about the location of other flight. So with its accurate, continuous and global capability, GPS offers seamless satellite navigation service that satisfy many of the requirements of aviation users. Right? Space-based position and navigation enables three-dimensional positioning determination for all phases of flight, from departure to route to arrival to airport surface navigation. Right? So for those all purpose, it's provide the position and navigation. Right? So this is about navigation, sorry, aviation, right? Mm, right, and we talk about the land, then the land related application in that we can say like road and highway. So we know, like you can see in the figure, like nowadays you have a system in your car, like you can enter the, it's kind of Google Map, right? You can enter the location and you will get the path. So you can say like using that application, using that facility, right? It will save our time. Right? Waste your time to find new places. Right? So it is estimated that the delay from the congestion on highways, street, and transit system through the world result in a productivity losses in the hundreds of billions of dollars annually. Right? So because of traffic, because of late delivery of some thing, right? Some product or something, right? Because of that, we have like face problem of we face like the business men have the loss, right? So this we can overcome through the GPS, right? Like if you have the proper location, you can easily navigate, so you will provide the particular thing on time, right? You will choose such a path where you don't have the traffic or any some other obstacle. Right? Then other negative effect of congestion includes property damage, personal injuries, increase in air pollution. Like if you know like if there is some traffic, then people are uh, they will, though their vehicle is not moving, right? They will will not they will keep on those their engine on, right? So because of that air pollution will occur, right? Also, because of that, power or the fuel consumption will increase. So after some year, we don't have that much of fuel, right? So such kind of problem can occur, and this all problem we can say the effect is reduced due to the use of GPS, right? So the availability and accuracy of GPS offers increased efficiency and safety for vehicle using highways, street, and mass transit system, right? Many of the problems associated with the routing dispatch of commercial vehicle is significantly reduced or eliminated with the help of GPS. This is also true for the management of mass transit system, road maintenance, crew, and the emergency vehicle. Right? So, in such all kind of system, we are using GPS. For the application related to road and highways, then for train also, for rail, we are also using the GPS or rail system. Through the world use GPS to track the movement of locomotive, rail car, maintenance the vehicle, and wayside equipment in the real time. When combined with other sensor, computer and communication system, GPS improves rail safety, security, and operational effectiveness. Right? The technology helps reduce the accident, delays, and operating cost while increasing the track capacity, customer satisfaction, and the cost effectiveness. Right? So, because of this GPS system, like in so like the city like Mumbai, right, where the population is too much, right? So we need to uh, have such public transportation system, right, that can manage that mass of the population. So you can see like on the same train after within some interval, right? Two trains are moving on same train, right? So because of that, the GPS location, they can avoid the accident. Otherwise, there is a chance of accident, right? So because of that, they will increase the track capacity, right? On same track, they can move more than one train. So such things are possible because of the GPS system, right? Because of that, it's cost effective, right? Otherwise, you have to make more tracks, right? So you have to spend more money, and also it will reduce the accident delay, right? Also, they will reduce like if some on some tracks some problem will occur on a train, right? And it is not moving steady there, right? Then because of the location, you can divert the other train which is on the same path, right? So that way you can avoid the delays. Then if you talk about the surveying and mapping, right? The application is related to your domain, civil engineering and infrastructure domain, right? So the surveying and mapping community was one of the first to take the advantage of GPS, right? Because it's dramatically increased productivity and resulted in the more accurate and the reliable data. Right? Uh, Today, GPS is a vital part of surveying and mapping activity around the world. Right? And not only part, right? When you use GPS in surveying application, mapping application, right? Uh, your accuracy is, we can say like maximum, right? Data of highest accuracy. So GPS based data collection is much faster than conventional surveying, right? So in conventional surveying, like people are manually surveying the land or right? So they're doing the mapping. So that conventional surveying and mapping technique, right? It's time consuming. Right? It will take more time. GPS based system is faster, right? It will reduce the amount of equipment which is needed, right? Otherwise, like when you are doing the surveying at the time, you need the equipment, right? Some civil engineering equipment, right? So when you use the GPS, you do not need that much of equipment, right? Also, you will require less labor. So these are the advantage. A single super surveyor can now accomplish in a one day what once took an entire team weeks to do it. So if you will do the surveying through conventional survey method, then maybe your entire team will take to complete the task within some week. So that same amount of work or the same task can be completed by a single person when you use the GPS. The geographical information system, which is called as a GIS, right? Which will store, manipulate, and display the geographically reference data. Also using the GPS system, right? Nowadays, most of we are using this GIS system, right? So for some research purpose also, some other application also, we can get the data from GIS, right? It will provide you the particular location data with the exact like longitude and latitude. Unlike the conventional technique, GPS surveying is not bound by constraints such as line of sight visibility between the surveys. Right? So, if you do the surveying through means manually or conventional way, then you can survey only the land where you can. It is on the same surface, like on the line of sight, like from one place to other place, it's visible, right? If the two places are that much of far, like from one place you can't see the another place. When the conventional method you can't do that, but in GPS, right, you can do that. Though your two uh, places are not on the line of sight, right? They are not in the, they are not visible. Still, you can do the survey, right, or mapping. The station can be deployed at a greater distance from each other and can operate anywhere with a good view of sky rather than being confined to remote helicopter as previously required. So previously in the conventional technique, if you need to cover large area, then you have to take the help of helicopter. Right? So nowadays you do not need. Hello, am I audible? Hello, hello, hello. Am I audible?
Yes, sir.
Okay. So that is about surveying and mapping. So that is on land. If we'll now we'll talk about this in the sea or in the water, right? Then GPS is especially useful in the surveying the coast and the waterways. Right? So where there are few land-based reference only available. Right? So when some you can say some ship, right? So cargo ship or passenger ship, right? And they will move on the sea. They will also use the GPS. Right? So the survey vessels combine the GPS positioning with the sonar depth soundings to make the nautical chart that alert the mariners to changing water depth and the underwater hazards. Right? So with the GPS, they will also use uh, sonar technique, right? So, uh, like when if you have seen some movie, right, it's based on like navy, right? So in that when they are want to track some other ship nearby, they will use the sonar technology, right? They will send a sound kind of signal, and from that they will find the location, right? I didn't remember one movie which is based on Indian Army. In that they, if you have seen that movie, then in that they are showing that they are using the sonar, right? So ultimately, I just want to tell that they are using GPS, right? So from that they will find like if is there any hazards underwater, what is the depth, right? In the water, because that is better to like uh, we know like ship size of the ship is very vast, right? So the most we can say like the large part of that ship is underwater, right? So they need to find the depth. Then the bridge builders and the offshore oil rings also depends on the GPS for accurate uh, hydrographic survey, right? So you know like we are getting oil from the sea, right? So that that surveying to find like where is the oil, right? And that also we are using GPS also when we want to make a bridge on some river or some lake, right? Uh, or on the water. At that time also we are taking the help of GPS. Uh, then the marine application. So GPS especially for marine application, right? Some application we have seen. In the last slide I was showing you, right? For surveying the water that is related to marine. So GPS especially for marine operation include the search and rescue. Right? So GPS provide the fastest and the most accurate method for mariners to navigate, measure speed, determine the location. Right? So this facility enables the increased level of safety and efficiency for mariners worldwide. Uh, Also, like commercial fishing fleets use GPS to navigate to optimum fishing location, right? Track the fish migration and ensure the compliance with the regulations, right? So for that purpose, the fishing industry, right, that also use the GPS. It is important in marine navigation for ships officers to know the vessel's position while uh, they are in open sea, right? And also in the congested harbors and the water, right? In the water also for the control the traffic or find the status of traffic, right? Or to find the location or the track of some ship, right? We are using GPS. An enhancement to the basic GPS signal. The technology is known as the DGPS, right? The differential GPS. It's provide much higher precision compared to the basic GPS, right? And because of that, it increases safety in its coverage area for maritime operation. Many nations right now using this DGPS, right, for operation in such way like device positioning. Am I audible? Hello?
Yes, sir.
My screen is visible, right?
Yes, sir.
Yes, sir.
So, so this using this DGPS can do like by positioning, sweeping, and degrading, right? So this buoy, buoy, correct? Buoy means a station which is placed in the middle of sea, right? Which will provide you like the information about the current in the water inside the sea. It will also provide some forecast some like like tsunami or that kind of uh, natural disaster, right? That information related to disaster they will provide, right? So that boys that will use this DGPS for like the positioning, right? And dredging means like when we are collecting the things which are at the bottom of the sea, right? So when we are doing the task, that is known as a dredging, right? So this enhancement improves the harbor navigation. GPS facilitates that facilitate the automation, right, in the marine. So the automation of pickup, transfer, and placement process of the containers by tracking them from port entry to exit, right? So from entry to exit at the port, right, we can uh, do the automation, right? That automation is because of this GPS. Right? So through that automation we can do like pickup, transfer, and the placement process. GPS information is embedded within a system known as a AIS, Automatic Identification System. Right? So the AIS uses a transponder system that is capable of communicating ship to ship as well as ship to shore. Right? So when they are moving from one place to another place, maybe it's cargo ship or some other ship, right? What they will do during the travel, they will also communicate with the nearby ships. They will also communicate to the shore, right? So if they have some problem, they can inform them, so they can get the help. They're transmitting the information relating to the ship identification, geographical location, vessel type, and the cargo information, all on a real time, right? And this process is fully, you can say, automatic. Right? These are the applications, right? And here. So in aviators through the world using GPS to increase the safety. Yeah, this slide we already covered. And the last application that the last environment application, right? So I think okay. So we will stop here. Tomorrow we'll start from this environmental application, and then we'll go further. Okay. Any doubt? Anybody have any doubt?